Hi everyone, my name is Christian Santos, and today we'll be learning about arrow functions and to this keyword as it applies to arrow functions. Arrow functions were introduced in ES6 or ES 2015 as a new and simple way of writing a function expression. Let's see how it compares to the old way of doing it. So on the left here, you see we declare our calculate total sales variable, and we set it to a function expression. Notice we're using the function keyword to define our function. Now, if we look to the right here, to the arrow function, you can see it's a very small change. All we did was we removed the function declaration and we added this little arrow, and everything else stayed the same. So in this example, you don't really see any of the benefits, but let's take a look at an example where it would be beneficial. So let's say we have a simple, short, is-even function. Once again, we're declaring this using a function keyword. It takes in one argument, and we're simply returning the number that we're given modulo 2, and we're checking if that's strictly equal to 0 to signify if that number is an even number. If we were to turn this into an arrow function, we simply declare an is-even variable, set it equal to an arrow function expression, where we have one argument. Once again, we still have curly braces, and we still have a return statement. But there's a shortcut we can use for functions that are short and sweet like this. For one thing, we can remove the parentheses around the argument list when there's only one argument. Secondly, we can actually remove the curly braces if we want to return whatever is to the right of the arrow function. In other words, we can have any expression to the right of the arrow function, and the result of that expression is going to implicitly be returned from that function. So you can see here it's a pretty, a very clean way of writing a function, especially compared to the initial definition. That brings us to our first benefit of arrow functions, is that in many cases, just stylistically and just in terms of readability, it's going to make some of your functions look better. I say some because really, as we saw in the last example, the benefit is greatest when you have short functions that are easily mapped to some returned expression like this. But of course, you can use it everywhere in place of normal functions, or I should say almost everywhere, as we'll see in the next slides, because there are implications under this keyword. You can see another example on the lower left here, where we have a multiply by 2 function that simply takes a number and returns that number multiplied by 2. However, let's say we have an add all function like we see in the lower right here, where we're given a number array. If we want to use a for loop and we want to declare variables, in that case, we do need our curly braces in order to make those statements. And we need the explicit return to have a return, similar to if we had, or I should say exactly the same as if we had a conventional function. So I mentioned that the first benefit of arrow functions was that they're a little bit cleaner. They can be a little bit shorter in some cases. But there's also another huge benefit to arrow functions, which is that they don't create their own this object. They inherit the value of this from their containing scope when that arrow function is created. Now, that's the golden rule of figuring out the this inside of an arrow function, is that it's set at the function creation time of the arrow function. So just remember that when you're looking at an arrow function and you see a this inside the arrow function, ask yourself, when was this arrow function created? Because when it was created, look at the outer scope. What was the value of this when the arrow function was created? And that's your this value inside your arrow function. Let's look at a concrete example here. So we have our delay variable. We say we point it to an object. That object has a delay by property, which is set to 2000. And we have a delay log, which points to a function expression. Inside of that function expression, we see here that we're calling set timeout, which is, if you're not familiar, it's used to, given a function, it'll delay when that function is called by some number of milliseconds. So in this case, we're saying delay this inner function that's going to log something and delay it by this dot delay by milliseconds, which is 2000 milliseconds, or in other words, by 2 seconds. And if we were to evaluate what the value of this was, let's start by looking at the function invocation of delay log. So we see that delay log was called by using object.notation, delay.delay log. So that means that inside of the delay log function, this is going to be equal to the delay object. And then inside of the set timeout, because it's an arrow function and because we're creating it right when that delay log function was called, that means that the arrow function, the this in the arrow function is going to be equal to the this in the outer scope, which in this case is the delay object. So after 2 seconds, this inner function is going to run and it's going to print this is delayed by, and then it's going to say this.delay by, which is, it's going to print 2000. If this was a normal function declaration in set timeout, it wouldn't work. It would say this is delayed by undefined, or it might even throw an error if we're in strict mode, because this in strict mode, when this isn't set, it'll just be undefined. Let's look at another example. So let's say that we wanted to take our previous code and clean it up a little bit. So we're going to take that inner function that used to be inside of set timeout, and we're going to now redeclare it in the outer scope. Let's think about what's going to happen here, and let's do the tracing exercise one more time. So first off, we call delay log using the object.notation. Therefore, inside of give it away there. So inside of the delay log function, this is going to be equal to the delay object. However, when we call set timeout, we're going to pass in the log arrow function, and we're saying delay that function by this.delay by milliseconds, delay by 2 milliseconds. So 2 seconds pass, and once we have to call our log function, what's going to be the this inside of that log? Well, remember the golden rule is when was this arrow function created and what was the value of this in the outer scope. So in this case, the log function was actually created even before the delay object even existed. It was created just in the top level scope. Let's say we're just running this in the browser and it was declared globally. Therefore, this just points to the window object. So this is going to print, this is delayed by undefined. Taking a few more examples here of the comparing just conventional functions and arrow functions, you can see this example here where we have a delayed printer constructor. We know it's a constructor because conventionally constructors have the capital letter, in this case the capital D, and because we're calling new delayed printer, when you call new on a constructor, the this inside of that constructor is going to be automatically created for you to be set to an empty object. So that's what it is inside of the delayed print body by default. But also notice that we've declared another function called inner helper, and then we're invoking that inner helper function. Whenever you have a normal function declaration, that function is going to receive its own this object. So that's important to keep in mind here, because it means that if we call inner helper, even though delayed printer has this set to an object, because inner helper is its own function declaration, this is actually going to be equal to window if we're running this globally, or undefined in strict mode, and globally this strictly equals window. And to get around this, it's pretty simple. We once again just redeclare inner helper to be an arrow function instead of the function declaration. And it solves our issues because now this will just be the value at the time the arrow function was created, which is where this was set to the empty object created by the new calling delayed printer with the new keyword. One more example here to really drive this point home and to see the sort of conversion from a normal function declaration to an arrow function. So we see here that we have an employee object. Once again, we have a few properties. We have greet message, we have kids, which is an array, and we have the greet kids method. If we look inside of the greetKids method, we see that in order for us to use the this object in some inner function, we have this pretty common hack that you used to see a lot in older code bases, where you save the this object into some variable. In this case, we call it _self, so that when we iterate over this.kids, which is an array, using for each, we pass in a function expression to for each, and we use that _self here to refer to the this of the containing scope. Now, if we have to do it this way, if we're using a normal function declaration, because if we were just to do this.greetMessage, once again, it's going to be undefined, because that function expression, since we're using the function keyword, it's going to create its own version of what this is going to be. So we used to see this all the time, but thankfully now with arrow functions, the solution's pretty simple, and this code is pretty much equivalent to what we had before. Since we're implicitly just getting to this value of the containing scope, we no longer need that hack where we need to reassign the this to some variable before using it in inner functions. This is also a pattern you see all the time, for example, in React, when you have some kind of handler. It's really common to use, if you're using a class component, really common to use an arrow function so that you still have access to the this keyword. Although even that's becoming much less common now that we have hooks. Okay, so let's summarize some of the key differences. Arrow functions have a simple syntax, and they don't need curly braces for implicit returns, whereas normal functions do, right? It's not optional. You need the curly braces, and you need to explicitly return your statements. Arrow functions cannot be used as constructors, and they don't have a prototype property, whereas normal functions, of course, can be used as constructors, and you can build an entire prototype chain just using functions. With that said, the modern way of doing it is using the ES6 class keyword, but under the hood, sometimes it's also just nice to know that we could recreate prototype chains just using functions. The this inside of the function in arrows refers to the this of the outer function when the arrow function was created. And I mentioned before that that's the golden rule of knowing the this in arrow functions. So just if you take anything away from this, it's that the this in arrow functions is set when that arrow function is created to whatever this was in the containing scope when that arrow function was created. The this inside of a normal function declaration depends on how the function was called and whether or not that function had the this hard-coded using bind, call, or apply. In contrast with arrow functions, even if you try calling an arrow function with bind, call, or apply, doesn't matter. The fact that it's an arrow function means it's always gonna just inherit the this from the containing scope. If you try calling it with apply, it's not gonna, or call, it's not going to throw an error or anything. It's just gonna ignore it, and it's going to always just stick to the normal definition of getting the whatever that this was in the containing scope when the arrow function was created. And that's it. So in summary, just be mindful when you use arrow functions. Most of the time, it doesn't really matter if we don't care about the this keyword, but in cases where we do, it's important to think about how arrow functions and normal functions interact with each other. Thanks so much for joining, and I'll see you in another lesson. Thanks.
Want to become a software engineer at Google? You can, like thousands of our students. You just need to learn from those who've already cleared FANG interviews. At Interview Kickstart, our interview prep courses are developed and taught live by 150 plus instructors from Tier 1 companies like Google and Facebook. Our courses are tailored to help you crack software engineering domain interviews, including back-end, full stack, machine learning, embedded systems, data science, and more. To learn more, book your free webinar slot today